This class we discuss about bandwidth. Bandwidth is the range of frequencies between F2 and F1 for which the power dissipates in the resistance R is equal to or greater than half power dissipated at resonance. Here F1 is called as lower frequency, F2 is called as upper frequency. IR is the current at resonance. I1 is the current at frequency F1. I2 is the current at frequency F2. Power at resonant frequency is equal to IR square into R. That is resonance current R square into R. Power dissipated at F1 is equal to I1 square into R divided by 2. That is equal to 0.5 into I1 square into R. Power dissipated at F2 is equal to I2 square into R by 2. That is equal to 0.5 into I2 square into R. I1 square into R is equal to I2 square into R is equal to IR square by 2, that is equal to 0.5 IR square. Therefore, I1 is equal to I2 is equal to 0.707 IR. I is equal to modulus of P divided by Z. I simplify it. At resonance, XL is equal to XC is equal to R or XL minus XC is equal to R. So, XL minus XC by R is equal to R by R is equal to 1. XL minus XC is equal to 0 at resonance frequency FR. In this case, frequency is increases from resonant frequency to F2. Here, inductive reactance XL increases by 0.5 times R. Capacitive reactance Xc decreases by 0.5 times R to satisfy 2 pi L F2 minus 2 pi L Fr, that is equal to 0.5 R. 2 pi L, I take it out common, F2 minus Fr is equal to 0.5 R. So F2 minus Fr is equal to 0.5 into R divided by 2 pi L, that is equal to R by 4 pi L. Similarly, frequency decreases from FR to F1. Inductive reactance XL decreases by 0.5 times R. Capacitive reactance XC increases by 0.5 times R. Here 2 pi Fr into L minus 2 pi F1 into L is equal to 0.5 R. Again 2 pi L into Fr minus F1 is equal to 0.5 into R divided by 2 pi L. Fr minus F1 is equal to R by 4 pi L. F2 minus Fr is equal to R by 4 pi L. Fr minus F1 is equal to R by 4 pi L. I can easily calculate F2 minus F1. F2 minus F1 is equal to R by 2 pi L. Here F2 minus F1 is called as bandwidth. We can derive the bandwidth frequency F2 minus F1 in another way. The range of frequencies F2 minus F1 is 1 by root 2 into resonance current IR is equal to 0.707 into IR. IR is the resonance current at resonance. Power delivered at resonance is half into IR square into R. So half into IR square into R is equal to current at band square into R. R get cancelled. So current at bandwidth is equal to IR by root 2, that is equal to 0.707 IR. Here F1 and F2, the power delivered to R is equal to half power delivered to R at resonance. So 0.707 into IR is equal to 0.707 into V by R. At resonance, XL minus XC is equal to R. So V divided by root of R square plus XL minus XC the whole square. Here XL minus XC is equal to R. Therefore, V by root of R square plus R square, that is equal to V by root of 2R square, that is equal to V by root 2 into R. Again I equate it, root 2 into R into V is equal to V into root of R square plus XL minus XC the whole square. Here root 2 into R is equal to root of R square plus XL minus XC the whole square. I squared both sides. I got 2R square is equal to R square plus XL minus XC the whole square. Again I simplified, 2R square minus R square is equal to XL minus XC the whole square. R square is equal to XL minus XC the whole square. Here XL is equal to omega L, XC is equal to 1 by omega C. Therefore R square is equal to omega L minus 1 by omega C the whole square. Omega L minus 1 by omega C is equal to plus or minus R. So I can rewrite the equation, omega square into L into C minus 1 divided by omega C is equal to plus or minus R. Again I simplified, omega square into L into C minus 1 is equal to plus or minus R into omega into C. Again, omega square into L into C minus 1 plus or minus R into omega C is equal to 0. Now I can rewrite the equation, omega square plus or minus R into omega by L minus 1 by LC is equal to 0. Now I got two values of frequency, omega 1 and omega 2. Omega 1 is equal to root of R square by 4 L square plus 1 by LC minus R by 2L. Omega 2 is equal to root of R square by 4 L square plus 1 by LC plus R by 2L. Here R square by 4 L square is very less compared to 1 by LC. We neglect R square by 4 L square. Therefore omega 1 is equal to 1 by root L into C minus R by L. Omega 2 is equal to 1 by root LC plus R by 2L. 2 pi f1 is equal to 1 by root LC minus R by 2L. 2 pi f2 is equal to 1 by root LC plus R by 2L. Now f1 is equal to 1 by 2 pi root LC minus R by 4 pi L. f2 is equal to 1 by 2 pi root LC plus R by 4 pi L. Now I can easily find f2 minus f1. Here f2 minus f1 is a bandwidth, that is equal to 2 into R by 4 pi L. So f2 minus f1 is equal to R by 2 pi L. This way also we can derive the bandwidth. With this I conclude my lecture. Thanks for listening.